All right, lesson one. These are the notes for lesson one. Okay, we might be able to get out through all of them today. If not, there'll be another video to finish them off. All right, so you're going to be responsible for the following formulas and facts. And we're going to have timed quizzes because we need to be accurate in a fast manner to score very high on these PSAT, ACT, and SAT exams. Okay, we're going to be talking about basic multiplication, fractions, percents, all of these. If you were to pick three of them that you most struggle with, or that you think you would struggle, which three do you think you'd struggle from these listed above? Don't be shy. Which ones do you think that most students struggle at your level? Systems of equations? Okay, I would say yes, a little bit. And we're going to aid that with a calculator today. We're going to learn how to do it by hand very, very efficiently. And we're going to aid it with a calculator possibly today. What else? This is the number one thing that people struggle with. So exponent rules, people just forget them. Okay? We just did linear equations, and we saw how it could be a little bit different when it's that x minus 1. But there's a couple others that also are very important that people struggle with. Rewriting equations for sure, because of the fact that this is the verbiage. Okay, so the verbiage of math and being able to put it in those equation-based forms is something people struggle with. And the other thing that, in my opinion, is huge is the factoring. Okay, being able to factor by hand quickly and knowing when and where to use the quadratic formula and whatnot. Okay, so let us begin. When you take these quizzes, guys, and those of you who are taking this online, there are quizzes for each lesson at the end. Okay, there's a lot of equations that they have included in the quizzes that you're expected to build fluency of and just memorization of as well. So here we go. We're talking about a circle, and C is equal to what? 2 pi r. That's the circumference of a circle. What's another way we can write that? Pi d. The one that's most common is 2 pi r. What's A equal? Pi r squared. There's the area. And if you ever get those two mixed up, which a lot of people do, know that area is two-dimensional. So that's why that one's going to have the squared piece, because that's two-dimensional. Okay? This next one is a square. What's P equal to? 4x, if we say that the side is x, good. And if it was s, we'd say 4s. What's A? X squared. What is this rectangle's P equal to? Let's say that this is L and this is W. Yep, 2L plus 2W. And what's A? LW. Now this one's a little bit different. The shape is a triangle. And what's the area formula for a triangle? 1/2 times base times height. Now here we go. The base is this guy right here. Okay? If that's the base, then the height is here. Because it meets at what? 90 degrees. A right angle. Okay? Now, this is 1/2 times base times height. Can someone tell me what kind of triangle this is? By name. Not isosceles, but close. Scalene. Scaling means when the angles, none of the angles are the same, and none of the sides are the same. Okay? Now, orientation, it's all about perspective. You could have also seen this as a base, and you could have also seen this as a height. If and only if, what? It's a right angle. Okay? So remember, the base and height are always perpendicular to one another. We are mastering content, not relearning it. Okay? So, cylinder, what's V equal to? Pi r squared h. You might have learned this also as capital B times h. And these capital B's that you see on formula charts, it's the area of the base. So if the base is, what shape is this, guys? A circle. So we know that that's pi r squared from what we did up here. All we have to do is just matriculate through with a height, and you're just stacking quarters, if you will. So you multiply by height and you get volume. Okay? Now you have a cube. Let's call this x. This would be x. This would be x, obviously, right? What's the volume? X cubed. Okay? Now, a little bit of extra FYI. Here we go. I need you to understand that if the bottom shape was a square, can someone tell me what would this length be in variable form if this was x, this was x, and this was x?
X root 2.
Nice. This would be x root 2 because the base is a right triangle. It's a special right triangle of x, x, x root 2. Otherwise, a 45, 45, 90 triangle. Okay? Now, with this in mind, I don't expect you to know it, but if you did, even better. Sometimes they will ask questions that go from this vertex or vertex to this vertex. What would that equation be? This is x root 3. No worries. If you want to do the math tonight at home, that's fine. But it's basically creating this Pythagorean right triangle. Okay? So you have x root 2 is one of the pieces that we just said. This one's x, and when we do the Pythagorean triple, otherwise Pythagorean theorem, this becomes x root 3. Okay? Last but not least, rectangular prism. What is the volume formula for this one?
X times width times height.
3 times width times height. Perfect. Let's move on. All right, Pythagorean theorem. Yep, a squared plus b squared equals c squared. If and only if this triangle is what? Right. Where does c go, or does it matter? It's the hypotenuse. So it has to go here, right? C or c squared?
That's C.
C. Okay. So where does a go?
Doesn't matter.
It doesn't matter. Some people say the shorter side, but it doesn't matter because why? They're being added. And when you add in math, does order matter? No. 5 plus 2 is the same as 2 plus 5. What other operation besides addition does order not matter? Multiplication. So addition and multiplication are commutative. It doesn't matter the order. Which ones does the order matter? Subtraction and division. 5 minus 2 is not the same as 2 minus 5, just like 5 divided by 2 is not the same as 2 divided by 5. Yeah?
Wouldn't that just be b and a, not b squared and a squared?
Ooh, nicely done. Nice catch. Nice catch. So that is a common mistake as far as how we label stuff, and I think we do it with conic sections as well. But we are definitely using this to find those sides for sure. Nice catch. Let's go to the Pythagorean triples. You learned this, that all this means is that these are triangles, right? Triangles that are right and that work with Pythagorean theorem. Otherwise, here we go. They work as 3 squared plus 4 squared is equal to 5 squared. So this checks out. Real quick, I'm going to spiral this in right now. There's something called a triangle inequality theorem. And what it means is, another way that you can see that this is going to be a triangle that could work is the following. 3 plus 4 must be bigger than 5. No multiplication. 3 plus 5 must be bigger than 4. And finally, 4 plus 5 must be bigger than 3. They are, so it at least is a triangle. Okay? Because of the Pythagorean triple working, we know it's a right triangle. What's 5 squared? 25. 12 squared? 144. What is 13 squared? 169. So this one also works. These are the most predominant ones that you will see. But you can have manipulations of them as you see right here. What is it that they did to get the second line? Just multiplied all of them by 2. Multiplied all of them by 3. Multiplied all of them by 4, and it still works. Because we learned in geometry what things that would make this work. There's 2 things. Proportions with similar triangles, right? Like you could have 3, 4, 5 proportion with 6, 8, 10. You with me? And then the other thing was a scale factor. Okay, so these are scale factors of 2, 3, and 4. Let's check out your number sense now, okay? What's 7 squared? 49. What's 24 squared? No. So without a calculator, let's do the number sense. Okay, we'll build that. What's 25 squared?
625.
Okay, 625. So, if I may ask, how did you know 25 but you didn't know 24? What is it that you remember that helped you with 25?
I just remember like how many 25s there were in 100. I just gotta remember.
Perfect. Okay, so let me show you something. Again, this is where the you will adopt it or you won't comes into play. And I promise you, if you adopt it, you're going to strengthen your math foundations by a lot. Here we go. If you have a number that ends with 5 and it's squared, not multiplied, but squared, it will always end with what? 25. Can someone tell me what number comes after 2? 3. So multiply 2 with that number that comes after it. Done. There's a nice little trick. Let's say that I had 45 squared. It will end with 25. What number comes after this one? 5. So 4 times that number that comes next. There's your answer. So anything that is square that ends with 5, there's a trick for you. Okay? Now, we had 24 squared. Now guys, what I'm showing you are not just tricks with easy numbers. These tricks also are tied with other things that people struggle with, like factoring, distributing, folding, all that other stuff. Okay? 24 squared is the same as that. Do you agree? Okay. 24, I'm going to make this into a folding problem. Okay? Now here we go. First, we multiply that to get 400. Okay? So, in folding, the outside and the inside are 2 sets of 80. Do you agree? So it's like saying 80 plus 80, otherwise 2 sets of 80, which is 160. Okay? And last but not least, let me gray this so that you can see the color of what goes with what. Last but not least, we're going to do the last terms, which is you get what? 16. Okay, so this is FOIL method, guys, but all this work that we did, it's just for me to teach it to you. After you learn it, you don't have to show any work, and that's why I want you to learn this, because there's no work need to be shown at all. So, we're not going to do FOIL this way. We're going to do it, oops, backwards. Okay? Now watch. Don't let this confuse you. Watch. Here we go. 24 squared, we're going to do 4 squared. What is that? 16. Carry the 1. Next, we're going to do the first times the second number, which is what? 8. Times 2, because there's 2 of them on the outside and inside, right here and here. So 8 times 2? 16. Plus the carry, 17. So now you have another carry because you have 17. The last bit that you're going to do is simply look at the first term. What's 2 squared? 4. Add the carry. There's your answer. We're going to do about 3 or 4 of these so you can see it. I hope you use it. It's huge, okay? Here we go. All right, so give me a 2-digit number anyway. 47. Here we go. 47 squared. We're going to first do 7 squared, which is 49. Oops. 49, we're going to carry the 4. Okay, so you've carried the 4. Keep that 4 in mind. Now multiply those two. What's that? 28 times 2? 56. Plus that carry of 4 that we did, 60. Carry the 6. 4 squared is 16. Plus the 6, 22. Done. Now I only showed this because of instructional purposes. I don't have to show it. I can memorize it and just go through, okay? Give me another 2-digit number.
75.
75. Okay, that's an easy one because it ends with 5.
79.
Okay, 79. Because if it ends with 5, guys, what will it end with?
25.
25. What's this number going to be right here? 7 times the next number, which is 8, would be 56. Okay? So let's go over here. We're now going to do our shortcut as far as the FOIL method. Here we go. 9 squared is 81. Carry the 8. 7 times 9 is 63 times 2, 126, plus the carry of 8, 134. Carry the 13. So now 7 squared, 49 plus the 13.
62.
62. Your answer is there. Questions? Alright. So this will work also. Listen, listen. This will work if they are not the same. Okay, let's work through this. The first ones are the last terms, which will give you 24 with the carry of 2. And then concentrate on 12 and 12, right? Which is 24, plus that carry, which is 26. Another carry of 2. And last but not least, 6, 7, 8, done. Okay? I hope you adopt those. They are nice and helpful. They help you big time with number sense. Okay? Alright. Help me out with these 3 numbers. What would they become? 10, 24, what? 26. Next one? 15, 36, 39. Just multiplying by those scale factors. Next one? 20, 48, 52. Now we're going to do these scale factors. We're just doing number sense and speed with the 7, 24, 25. What would this be? 14, 48, 50. And then? 21, 72, 75. Last one. 28, 96, 100. Nice number sense. Nice speed as well. Okay? And yes, you could check it. 28 squared plus 96 squared would equal 100 squared. Alright. Special right triangles. Now you've used them. You've worked with them. Why are they special? Because they're angles. This and this are still angles. But these aren't special.
They have like 60 degree angles, but because of like, I don't know how to express it in words.
No worries, no worries. Have you taken pre-cal yet?
No.
Okay. So in pre-cal, you work with the trigonometric functions a lot more and their ratios. Sine, cosine, tangent, SOHCAHTOA, right? Sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. These ratios are built pretty much from right triangles. And these two are special because these two pretty much built pre-cal. All of trig comes from these 2 triangles. The ways, the different functions that you manipulate in pre-cal, they come from these 2. Can you tell me what shape did the 45, 45, 90 come from? Came from a square. And on that last slide, we said that the shape of a square had a side of x. So if this is x, what's this side right here? X. And what would this side be? x root 2. Now, we have x root 2 memorized. A lot of us do. Do we know why it's x root 2? If you haven't ever seen this, check this out. Let's pretend that this hypotenuse is just question mark for right now. But I did know that the legs were x and x. Pythagorean theorem says we could do x squared plus x squared is equal to question mark squared. Guys, what's x squared plus x squared? 2x squared. Not x to the fourth. Because you're not multiplying. And this is where a lot of confusion comes into play as far as what we were saying earlier, as far as what people forget and struggle with of mastery. Okay? So if I'm adding x squared and x squared, I get 2x squared is equal to question mark squared. Help me get this by itself. What do I do to both sides? Not divided by 2. Square root it. So if I square root it, I have question mark. Can I take the square root of 2? No. But I can pull out the square root of x squared, right? As what? X. This is why this is x root 2. Not just the memorization, but this is why it works. Okay? What shape did this 30, 60, 90 come from? Not a rectangle. Not a square. Not a circle. This came from an equilateral triangle. Okay? So they're all how many degrees? 60. Notice that this one's cut in half. So if this is cut in half, that means this is the same as that. Let's label this x. What other side do we know if we are labeling this as x? Hypotenuse. The hypotenuse is 2x. Pythagorean theorem says a squared plus b squared is equal to c squared. What's wrong with what I just wrote? We're going for mastery. What's wrong with what I just wrote down? It should be parentheses so that it's 4x squared. Go with me? So now let's solve for question mark. How do we get question mark by itself? Subtract the x squared. So we have question mark squared equals 3x squared. And guess what? When we take the square root here, the 3 will stay in and the x comes out. That's why we have these charts of 30, 60, 90, x, x root 3, 2x, and 45, 45, 90, and x, x, x root 2 memorized. Because if we get something that looks like the following, we can use these tables to quickly find the answers. For instance, let's say that opposite from 60 was, actually opposite from 30 was 10. What would this be? 20. What would this be? 10 root 3. If you didn't get that as fast as he just did, we know the opposite of 30 would be 10. So it would be in the 30 column. Now all we have to do is set these two equal to each other and solve for x. So that means x is 10. X is 10 here, and x is 10 here. So that we'd get 10 root 3, which should be the opposite of 60, which it is. And we would get 20, which should be the opposite of 90, which it is. That's how you use those tables. Let's do a difficult one with these tables. Let's say that we were going to do 45, 45, 90, but that this time they put this as 10. You with me? So opposite of 90 is 10. Now let's solve for x. What do I do? Not square both sides, or square root. Divide by root 2. So that cancels to 1. And I'm almost there. I can't have an answer that looks like that because of why? Rationalize the denominator. I got to get rid of that radical sign in the denominator. Now, this is very important what I'm about to say. How do I get rid of that? By multiplying by what?
Root 2.
Nice. Root 2 over root 2. Which is a form of what?
1.
1.
Nice. So to multiply forms of 1, we can manipulate what things look like. Just like we can add by forms of 0. That's even more difficult, but that's higher level. We'll stick to this for right now, okay? What does the denominator become? 2. What does the numerator become? 10 root 2. And I simplify by reducing those two so that it equals what? 5 root 2. Because guys, look, x is now 5 root 2. So everywhere where you see an x, we're going to put 5 root 2. So opposite from 45 is 5 root 2. Opposite from the other 45 is 5 root 2. I hope that you know how to use these tables now. Okay? What's the sum of the degrees of the measures of a triangle? 180 what? Degrees. What's the number of degrees of a straight angle? 180. What's the fancy word for that? Supplementary. Okay? What's the total arc measure of a circle in degrees? 360. And what's the total arc measure of a circle in radians? 2 pi. Now some people don't know this. Now watch. A circle has 360 degrees. If I told you that the radius was 1, which we learned the unit circle in pre-cal, what would the circumference be if the radius was 1? 2 pi. So 2 pi is quote-unquote representing the same as 360 degrees would. Okay? So if 2 pi is 360, how much would pi be all by itself? 180. So pi radians is the same as 180 degrees. You with me? So let's do a couple things real quick. I want to change 3 pi over 2 radians, and I want to change it to degrees. What do I multiply in order to get my answer in degrees? 180 over pi. Because the radians are going to cancel, and I'm left with the degrees on top. Guys, what would you do here? I have a 3, I have a 180, and I have a 2. What should we do to make it easy to do it by hand? Always reduce as early as you can before multiplying. Okay? So this is 90 over 1, and what's 90 times 3? 270 degrees. We're going to convert from degrees now to radians, and then we'll be done with this. So, let's look at 330 degrees. We're going to convert it to radians. What's the conversion factor?
180 or
Pi over 180. So, here we go. Do you see a nice number that 330 and 180 can reduce by 30? By 30, yeah? Because the top would be what? 11. And the bottom would be what? 6. So it's 11 pi over 6 radians. Now some people didn't see 30. Some people said let's just do 2. And a lot of people like to do the 2, or they'll like to do 10s or things like that. Whatever's comfortable for you, by all means use it, but learn how to build a higher level of GCFs whenever it's possible. Alright. What's the equation to change a fraction to percent? Times what? Not 10. Percentages all revolve around how much? We were talking about that on the activity question. 100%. So the equation is multiply this by 100, and then you can get it to percent. Okay, here we go. 1 over 10, 100 over 10. Do these reduce? Yes, because they're being what? Multiplied, right? So 100 over 10 will reduce to what? 10%. How do I now move it to a decimal? Move the decimal 2 to the left. Done. Okay. 1/5. It'll reduce to 20%. Otherwise, 0.20. How about 1/4? 25%, which is 0.25. This one's a little bit different. First, we're going to reduce the 100 and the 10 to what? 10. But then we need to multiply by whatever's left, if it's not 1, to get what? 30%. Moving the decimal over, 0.30. What's 1/3? 33.33 repeating percent. Right? So what would this be, decimal wise? 0.33 repeating. 2/5. 40%, otherwise 0.40. 1/2, that one's the easy one, 50%, otherwise 0.50. Know how to go back and forth between all of these very quickly, okay, by hand without a calculator. So 3/5, 60. And guys, these fifths you see a lot. How many $20 bills are in 100? 5. So if I'm looking at 3 $20 bills, right, that's another way to quickly understand that it's 60%. How about 2/3?
66.6.
Yep, 66.66 repeating percent. Then we have 0.70, otherwise 70%. Then we have 0.75, 75%. Okay, so again, I have 4 $20 bills out of 5. So there's 80.80 or 80%, 0.90, and 90%. Good. All right. They say they want you to know, aka memorize, these. Now here's what I'll say. I think the only ones that you really have to memorize to, if you want, is 12. If you want to know and use the FOIL trick. Okay? Now, if you're in number sense, UIL mathematics, they have the first 35 memorized, just like that. In cubes, they have the first 15 memorized. Like if I said what's 12 cubed, they'd be 1728. They know them that quick. Now, if you want to do that, that will strengthen you even more. And those that are on number sense UIL math, I promise you, they all have scored perfect on the PSAT math sections. Okay? Let's keep going. 1 squared. 1, 4, 9, 16, 25. Okay? 49. Good. Mm-hmm. Oh, so it goes to 144, maybe 169, and then kind of gets a little bit weird, right? In case it gets weird, let's do the trick that we learned. 4 squared. 16. Carry the 1. 4 times 1? 4. Times 2? 8. Plus the carry? 9. Is there any carries right now? Are there any active carries right now? Nope. So the last thing is, what's 1 squared? 1. 15 squared will end with what? 25. What's the number that comes after 1? 2. What would I get? 2. Nice. So here we go. 6 squared is 36. Carry the 3. 6 times 1 is 6. Times 2 is 12. Plus the carry of 3. 15. With a carry of 1. What's 1 squared? 1 plus the carry? 2. Okay, here we go. 17. What's the last number that I'm going to write? 9. Carry the 4. Then I have 14, right? Plus 4. 18. Carry the 1. What's the last number, all right?
2.
289. So if you could do this fast, which just takes practice, no matter where you're at with math, just takes practice, you could do these without memorizing this. Okay? 8 squared,
324.
or 64, right? And then carry the 3. Then 8 times 1 times 2, 16, plus the carry of 6,
Is
22. So now I have a carry of 2, that my last number will be 324. We know this is going to be 400, right? This will end with what? 1. Carry the 8. 18 plus the 8? 26. It's the last number. Nice. Guys, look at that. No work. And it just takes like 5, maybe 5 problems of practice. And continue the practice. Can you do this trick if it was a 2-digit by a 3-digit? No. That's a different thing. Okay? These are only 2 digits by 2 digits. And what we just did with that FOIL method, which one of these 3 did we do? A plus B squared. Is this a sum of squares? No. Because a sum of squares, if it existed, could look like this. Whoops. If it existed. 4 plus 25. We know this exists, right? What is it? 29. But if a sum of squares exists, that means you can factor them. You understand? Does a difference of squares exist? Yeah, a difference of squares does exist. And a difference of squares looks like this. You with me? Can y'all help me out? Like, what is going on here if you were to factor this out? If you were to factor this line that you just see, let me highlight it. If you were to factor this, this is where the factoring comes into play. Do people know how to factor to that, top less than 0.5% level? What would this be? Nice try though. It's not. You're thinking of something else. You're thinking of this. This is a squared plus 2ab plus b squared.
5 minus 2 times 5 plus 2.
There we go. So 5 plus 2, 5 minus 2. Because look, 5 squared, look at the visuals, I'm trying to help you as much as I can, is the first one. 2 squared is the last one. Can someone tell me why this is going to be a subtraction? Because the plus and minus multiply together, give me the subtraction. What happened to the O and I?
They cancel out.
They canceled out to what number?
0.
0. That's why difference of squares exists. Which one of these 3 is difference of squares? There you go. This one. A lot of people think it's this one because they see the difference and they see the square, but this is not a difference of squares. Because this inside and outside terms don't cancel to 0. What would this be if I distributed this one right here? If you don't see it right now, a lot of people don't see it like that. There was a fancy word that we used in Algebra 2 whenever we saw that 2. We'd write it down 2 times. If it was a 3, we'd write it down 3 times. It starts with the letter M. Do you all remember? Multiplicity. Multiplicity with these factors, okay? So if this is a multiplicity of 2, we know it's a squared. Look at this. Minus, right? 2ab plus b squared. Okay? Factoring, difference of squares, sum of squares which don't exist, and then these multiplicities. We're trying to iron all these out big time. So what would this be whenever we finish it? A squared minus b squared. A difference of squares. So guys, when you see this forevermore in this format, I hope and I hope and I hope that you notice difference of squares? Okay. Important math vocabulary for SAT, ACT. What are the coefficients that you see, guys? -3 and 2. What's the constant? -11. What's the degree? 2. Or second degree? What is an integer? I'm a 6th grader. Explain to me in simple terms what an integer is. A positive or negative whole number. So is 0 an integer? So we don't know. Okay, so here we go. If I told you to naturally count, otherwise the natural numbers, that's the sign for numbers, not just pound, but, or hashtag, whatever. So natural numbers, if I told you to naturally start counting, go ahead, what would you say? 1, 2, 3, right? You naturally always start at 1. And then if I said, I want you to tell me what a whole number is, would it be the same? It would be 0. And then 1, 2, 3. A good way to memorize that, guys, is that. Okay? And then integers include the negatives. And they're only the whole number jumps. No what? No decimals, no fractions whatsoever. So is the number 0 positive or negative? Neither. Given these two factors is equal to 0, we can say that 2 and -11 are solutions, otherwise answers, to the equation. What other ways that you can describe those? What other 3 words? Zeros, that was a big one. Roots. What's the last one? These are all the words that they'll use in the wording of the question. Yeah, x-intercepts. Nice. Good. Is this difference of squares? Yes or no?
No.
No. What would you do to this to make it difference of squares? Okay, so you would make the 2 into an 11, or you would make the 11 into a 2. But everything else satisfies, right? You have a plus and a minus. Nicely done. All right, formulas of linear functions. Again, guys, I understand that this is quote-unquote the easy stuff, but we need to master conceptual deep understanding, and we will be fine with these, and we won't miss the easy ones. Slope-intercept form, otherwise y-intercept. Point slope. And slope formula gives 2 points, given from 2 points. So in linear problems, slope is often referred to as the rate of change, rise over run, all that good stuff. It's the change, increase, decrease, and the y-intercept is often referred to as the initial value. Okay? So this is going to be our initial value, otherwise our phi, or one-time phi. And this is going to be our slope, otherwise amount per x. This is our slope here, and this is our point slope form, because you have a point and a slope that this comes from. And let's just refamiliarization with those equations. Then we have midpoint. See, midpoint, some people make midpoint much more difficult than what it needs to be. For instance, let's say that I have a graph, and that 2, 5, there was this point. And at -3, 4, there was this point. And I wanted you to find 2 things. What's the length of that is one of them. And on this length, where would the midpoint lie? To where this side was the same as this side. Let's do the distance formula first. Do you remember this formula?
That'd be a -4.
Oh yes, thank you. Do y'all remember that formula, the distance formula? See, neither do I. The distance formula to me was horrendous to memorize. And I remember my teacher would say, memorize this equation. I was like, that's way too much to memorize. Like, I would get these mixed up with addition, and I would put a subtraction there. But then I thought about something. All the distance formula is Pythagorean theorem. If I square both sides, this goes away, and that appears. Now I have a squared plus b squared is equal to c squared. All I have to know is verbiage. This is the difference between the x's. And difference between the x's is the distance between the x's. Can y'all tell me what is the distance between those two x's? 5. Because I could build a triangle, and this would be 5. What would the height be here? 9. Y'all see what I'm doing? So now if I do 5 squared plus 9 squared, and I take the square root, that's the distance that I'm going to get. So what is that, 106? And we'll rationalize and reduce those later. We're not going to practice with that now. But that would be your distance. It's a little bit over 10. Questions? All right, so what if I said, where's the midpoint? Now, without looking at this equation, this confused me too. And when I saw this, I know it was so easy, but it confused me until I thought about it. Guys, if I gave you a grade of an 80 on a test, and the next grade was 100, what's the midpoint? 90. All the midpoint is, it's synonymous with the word average. Now here's what people do. If I asked you to find the average between a -3 and a +2, you know what some people do? This was me included. This is what I used to do. I used to see that there was a jump of 5. Then I divide by 2, which would be 2.5. And then I would, from -3, go 2.5 that way, or from 2 go 2.5 this way, which would give me a what? -0.5. That's too much work, guys. If we're doing midpoint, please, please, please just add them together and divide by 2, because you're going to get the same thing. Okay, for both the y's and the x's. Okay. We have the percent change. As far as increase or decrease, it's the change over the original times 100. Okay, so let's say that I went and bought a video game for $60. Okay, but I ended up paying $65 for it. You with me? What would be the change? What would be the change if I paid $65 for it? $5. What's the original? 60. And if I multiply it by 100, it's going to tell me what the percent increase would be. Do you understand? What's 100 over 6 to reduce to? Or sorry, 100 over 60 reduces to what? 10/6. Otherwise, 5/3. You see what I'm doing now? So I get 25 over 3, which is a little bit over 7. Would you agree? So the tax rate, we could say it was like 7 point something percent. Okay, those are just example problems, just trying to throw them in with you right now so you see the application. Okay. You all remember this equation? The dirt formula, right? Distance equals rate times time. So if I solve for rate, what would that be? And if I solve for time, what would that be? Out of these 3, which one do you think, even though they're all the same, which one do you think people most struggle with? Actually, it would be this one. This one's weird. Like when I say the distance divided by the rate to equal the time, when people set it up, and you'll see the problems that we're talking about later this week, you'll see what I'm talking about. Equation of a circle, where r is the radius and the center is hk. big stuff here. If I have x minus 2 squared plus y plus 5 squared is equal to 25, who can tell me what the center of this circle is? 2, negative 5. Yeah. So center is 2, negative 5. What's the radius? 5. And guys, it comes from this equation. The radius is the square root of whatever that whole thing is. And here's a good rule of thumb that I teach all my students. Everything that you see in parentheses, you should always interpret the what? The opposite. So not a positive 2, sorry, not a negative 2, but a positive 2. Because that's what makes this x happen. You know what I mean? Your x-intercept is 2, making this whole thing 0. This is negative 5. So it's the opposite of what you see to make the whole factor 0. What's this the same as that you've learned? Pythagorean theorem. And distance formula. So if you don't know it right now, that's how it works. Okay? And you'll see and you'll correlate those as you go and as you practice throughout this week. All right. Evaluating powers. 5 cubed, which is 5 times 5 times 5 is 125. 3, and again I'm doing visuals just to help, are 2 groups of 9, right? Which is what? 81. What would 2 to the 5th be? 32. Because it gets you to the 16 times the 2 more, which will give you 32. 4 cubed? 64. This is common. Not a lot of people know it that fast. Okay? You tell me, which one could you memorize faster? And be honest. Four cubed. You'd remember 4 cubed faster than the cube root of 64. We're going to talk about this here soon, okay? But that they are equivalent, okay? And then 2 cubed, 8. Simplifying radicals. One of my favorite things to do, even with people who know and have good number sense. Guess what some people try to do with 50? They try to break it up like that factor tree that you were taught. And the number that they write here is what? 2. They write 2. Most people write 2. And then they see 25. And on this one, they see, ooh, I can take the square root of 25, which will come out as a 5. And the 2 stays here. Well, they got lucky. They got lucky with this too. But the things that I think you should be thinking about are not starting necessarily from 2. Let's see if you can follow the pattern. The first number that I would try is 4. And then 9. And then 16. Then 25. Then 36. Then, you know what I'm saying? What am I doing? I'm the squares of each, right? So this is 2 squared, 3 squared, 4 squared, so on and so forth. Okay? Look at 200, guys. What number do you think I'm thinking about? 25 could be a number. That's a big number, right? 25 and what? 8. But then I realize I'm going to have to pull out from the 8 and pull out from the 25. Will it work? It will work, right? Let's pull the 25 out first. 5 root 8. Now let's change 8. 4 times 2. What pulls out now? The 4 will come out by 2, right? So what's my final answer, guys? 10 root 2. Looking at this, what number should I have tried to divide out first? 100. So the key is finding that number sense familiarity of these numbers. When you build it, it makes you very strong. What's the biggest number that we can start pulling out? 9. So when this comes out as a 3, otherwise this 3 squared, 3 root 3. Okay? What's the cube root of 27? 3. Because it's asking what number times itself, this is for people who don't know, 3 times, what number would it be that would satisfy to get me 27? It would be 3. Okay? And then what's the 4th root of 81? 3 as well. Let me mix it up a little bit. What if I did something that looked like this? 64 squared cube root. It's just 64. Is this the same as that? Yes. Is this the same as that? No, it is. All of these are linked with multiplication. And what did you say with me earlier? Does order matter with multiplication? No. So you could do it in any order. Guys, would you rather square 64 and then try to cube root that? No, I wouldn't either. But can we cube root first? What is the cube root of 64? 4. And then square it? 16. Done. Stress on manipulations and stress on order with multiplication doesn't matter. Okay. Rules of exponents, and we will end with this today, okay? Rules of exponents. Hopefully this will help you really solidify that last one. When you multiply things with the same base, notice that the answer is only written with one base, not two. What do you do to the powers? You add them. So this would be 2 to the what? 9. And this one would be 3 to the what? 5a, not 6a squared. Okay? People see this multiplication and they multiply the powers, but they're forgetting the rule. So it'll be 5a. Okay? When you see things with the same base, again, one answer, one base in the answer, what do you do to the powers if it's dividing? You subtract. So what would this be? 2 to the 4th. Otherwise, 16. What would this be? 5 to the 2a. And this one, what would this be? So yeah, you're jumping a little bit ahead, no worries, you're good. So this is 7x to the negative 3 by the rule, right? By the rule, this is 7x to the negative 3. You didn't do anything with the 7, you just were looking at the powers and you subtracted because it was same base dividing. But yes, Braden is absolutely right. You cannot, sorry. Yes, Jackson, you are absolutely right. You are not going to write it like this. Just like you don't have square roots and denominators, you don't want to have negative powers. Okay? So we're going to move all negative powers to make them positive. The way I want you thinking about this is that this whole thing is over an understood what? 1. So that the only thing that's going to move is what's attached to that negative power PEMDAS wise. So 7 stays up top and the x becomes a positive 3 on the bottom. And this is most likely what you would see it as. Now, another way that I teach this is up top I see 2 x's. On the bottom I see 5 x's. And I see cancellation of forms of what? 1. Who wins? How much? By 3. Done. Okay? Let's go over here now to a power raised to a power. We're going to multiply those numbers. Guys, what's the best way do you think that you will remember that this is going to be adding and this is going to be multiplying based on how they're given to you? What's the best way for you to remember? To me, he said when you're squaring, you multiply. Yes, the thing that gives me a visual cue is the fact that there's a parentheses between m and n. And what do you do with parentheses 9 out of 10 times? You multiply. So to me, I see this multiplication, and then I would look at this and be like, oh, this one's addition. Okay? So this is going to be 2 to the what? 12. And this is going to be 7 to the xy. Nice. A little bit more, we're almost done. Just these last 3. When simplifying expressions with negative exponents, remember to cross the line and change the sign of the power. Big thing that I'm about to ask you right now. This is over and understood what? 1. So, did I do the reciprocal and flip this to get this? Yes or no? No. This 1 is different from this one. Okay? This one just went downstairs and became a positive. This green 1 is still there, we just don't write it. And the one up top was always there, it just wasn't written. Understood forms of 1 on top and bottom. Okay? So what would this be equivalent to? 1/8 or 1 over 2 cubed. Right? Alright. Which one moves? The negative b, right? So if it moves upstairs, what's my final answer? Times y to the b. All of it is in the numerator. Again, let's think about this as an understood 1. So the b moves, right? So my final answer would be what? Over b squared. So a cubed times c over b squared. X to the 0 is 1. Guys, this x can be any number except for what 2 numbers in math? 0 and what? Wait, who said that? Infinity. Infinity. Nice. So 0 and infinity are numbers and concepts. Infinity is just a concept, pretty much. This is why these 2 will not equal 1. Everything else will equal 1. Everything else will equal 1. Okay? So what's my answer right here? 1. Okay? 3 to the 0 is 1. X to the 0 is 1. Y to the 0 is 1. 1 times 1 times 1? Still 1. Okay? So, all of this mess to the power of 0, 1. Alright. Last one. Fractional exponents. This is the thing that we finished on the last slide with that cube root of 64 squared. X to the 1/2. Guys, nothing is written here, but what's understood to be there? What number is understood? 2. Yeah, 2 is understood to be there. It's not written. Just like 1 is understood to be here, but it's not written. Okay? So what would this 49 to the 1/2 equal? 7. It's the square root of 49. Otherwise, 7. Here we go. I have a choice. What 2 ways could I write this?
X squared, all that cube rooted.
Yep, 8 squared, all of that cube rooted, which probably wouldn't be the way that I'd want to do this, right? What's the other way? Cube root of 8, and then quantity squared. What's the cube root of 8? 2. Squared? 4. Much easier in my opinion. Okay guys, we will end with that. We'll pick up with this tomorrow.